Mean of a normal probability distribution. That means standard normal, the standard distribution. Okay. Normal probability distribution is 400 pounds. Standard deviation is 10. All right. Now it's asking for the area between 415 and 400. So just like we did before, we go here, 415. The mean is 400. And standard deviation was 10, right? Giving us a z-score of 1.5. That's pretty high, 1.5. Go to the z-table. Go to 1.5. And we don't even have to go to 1.5 anything, it's just 1.5. So we see 93.32% of the population lies below 1.5 standard deviations from above the mean. Okay? Now if we're thinking about the problem, that means that 0.9332 is the proportion of the population that lays below 415 pounds. Okay? Now, we gotta subtract 0.5 from that because we want the area between 415 and 400. Okay, we want the area between those. So 0.9332 minus 0.5 is going to give us 0.4332. All right. Up the area between the mean and 395. All right, well 395 is half a standard deviation from the mean, but it's below it. All right, so it's half a standard deviation from the mean. So it's 0.3085, right? So we need to take 50%, so 0.5000, and subtract 0.3085. 3085. And we get 0.1915. 0.1915. See? Now, the standard normal curve is symmetric, okay? Which means that being 0.5 away from the mean, below the mean, you're away by, what was it, 0.1915. If you're above by 0.5, you're also away by 0.1915, because you see 0.6915 minus 0.5 is just 0.1915. So even if you have half of the z-table, even if you have the positive half or the negative half, either one, you can still figure out all the problems, because this half, so you got 0 at 0.5, this half just you subtract by whatever you have, 0.0398, and here you add by 0.0398, see, to get the 0.1 here. So the z-table, you just need half of it. Alright, what else? Probability of selecting a value at random and discovering that it had a value of less than 395. Now that's just, we read straight from the table, right? Still 395, so it's 0.5 standard deviations below the mean, and the proportion of the population below 395 should be 0.3085. Okay. Well, let's see if the questions get any trickier. All right, mean of 50, standard deviation of 4. Mean of 50. Standard deviation of 4, right? So mean is mu, standard deviation is sigma. Compute the probability of a value between 44 and 55. Alright, so we're getting a little trickier now. So how are we going to do this? Right? Well, we're going to need two z-scores here, right? The one for 44 and the one for 45. So for 44, the z is negative 1.5. Love how these numbers are just working out beautifully. And the other one was 55. This number might not be as beautiful. 1.25. All right, pretty good. Pretty good. So between negative 1.5 and 1.25, right? Now, this I really want a picture of here. But if we go to the standard normal pictures, so let's say we wanted all the area between, we wanted the proportion of the population between negative 1 and 1. Okay, all the 68% between negative 1 and 1, right? So, you know, this is our barrier on the left, bordered by the standard normal curve, barrier on the right. Okay, that's should be about 0.68. Now, if we just had the z-table, how do we do that? Well, we see that the proportion we get for negative 1 is going to be this tail here, the area of this tail here. And the proportion of 1 is going to be the area of that tail plus this portion that we want to know the area of, right? So the higher value contains what the lower value has plus the area in between. So if we take this higher value, the proportion of the population below this higher value, right, is this whole thing, and we subtract the area, the proportion of the population below the smaller value, the tail, we're going to get the meat inside that we want from negative 1 to 1. We're going to get that 68%. Right, so you take the proportion of the population below the higher value, subtract the proportion of the population below the smaller value, and that's going to get you what's in between. All right. So if you draw a picture, it might even make more sense. So between 44 and 55. So 44 was 1 standard deviation below, which is negative 1 is their z-score. So the proportion of the population below that was 0.1587. Oh, excuse me, it was 1.5 below. So 1.5 is 0.0668. And this was 44, and this is 55. So 55 was 1.25 standard deviations above 1.20, 1, 2, 3, 4, 5. So that's 0.8944. 0.8944. Okay. Now what do? We take the higher one and subtract the lower one from it. And we get 0.8276. And our answer should be 0.8276. Good. Right? So if you want to find the proportion of the population between two values, right, you find the proportion of the population less than the bigger value and subtract the proportion of the population less than the smaller value. Alright, how about this one? Compute the probability of a value greater than 55. So 55 we already have, right? But the table that we have is telling us the area below it, right? Area below. So to get the area above, what do? Well, we know that the whole area is 1. All right, we know the value of the shaded area. So if we do 1 minus the value of the shaded area, we'll get the value of the non-shaded area, okay, the value above. Okay, so in this case, because of the way the z-table is set up, to find the value above the z-score, the proportion of the population above 55 in this case, we need to do 1 minus that 0.8944. Alright, so we go to here. So 1 minus this number, 0.8944, is that should be 0.1056, the proportion of the population above 55. Okay. And yeah, 1056, that's the answer. Alright, so how about between 52 and 55? Alright, so again, this is just asking us same question, just testing us a little bit. 52 here. And the z-score is 0.5 now, okay, so 0.5. So that's going to change the proportion of the proportion of the population that's below that. 0.5 on the z-score, right? 0.5. And that means that 69.15% of the population is below 52, right? 52 is our number. Sorry, I lost track. 6915. So now the proportion of the population between 55 and 52 is the same as the area between 1.25 and 0.5 on the z-scores. And that's the same as 0.8944 minus 0.6915, which is 0.2029. Okay, so we can make this chart area below z. This can be z. This can be value, right? And this can be area between. All right, let me make a little chart.